The plant has been here for 40 years, and things have changed. Maybe not everything has been properly aligned in terms of your engineering standards.
The plant was opened in 1969 by the Duke of Edinburgh, built to handle the North Sea gas bonanza, and it's still expanding. It now deals with a third of the country's gas supply.
It was late in the afternoon. It was starting to get dark.
Sitting down with the family, and Jeanette, my partner, said, "Paul, I think you better see what's going on the telly. I think there's been something going on at work."
Hearing a loud explosion just before 6 o'clock tonight. The terminal is at one end of a crucial cross-channel pipeline bringing in gas from continental Europe.
I was sitting at my desk and heard a sort of loud bang.
Initially, my thought, what is that? Is it from the Bacton gas plant? Is it a crane falling off?
Possibly something like a compressor backfiring.
And then when I looked around, I saw the smoke coming from the middle of the plant.
That's when I realized this is something major.
Shell said they couldn't comment on the cause of the fire until their investigation was complete.
The last thing I think most people expected was an explosion on a wastewater treatment plant. It's water. What the heck had gone wrong there to cause that explosion and that incident?
The wastewater treatment plant itself was put in place because the water stream, which used to just discharge straight to sea, was decided to be too high in terms of the glycol content. So we've got this wastewater treatment plant where bacteria eat the glycol essentially and reduce the levels down to a level where we can discharge it.
Our main focus was looking at the environmental effect and managing the process to make sure we met our consent levels for discharge to sea. And yeah, it was a water treatment plant. It was not deemed as a hazardous piece of plant.
A hole developed in the vessel VG110, the separation vessel, which meant that the condensate separation step was effectively being bypassed and you were getting more condensate than usual through to the buffering tank. When we looked at that on an operational basis, we were concerned primarily with the effect that that would have on the biomass. So we instigated some routines to try and get that pumped out routinely, but we didn't really look at it from the side of potential explosion.
As you can see behind me, the damage was fairly significant. What actually happened was the explosion occurred in an enclosed concrete tank, taking all the steelwork with it. There was steps, stairs, handrails, etc., which were above the tank, which were all destroyed.
We had a number of operational issues with the plant where the biomass wasn't very healthy. Finally got into a stage when it was ready to start operation again, and at that stage it was noticed that the level control of a tank further down wasn't working properly. To try and get around that, operations had put that in process in manual. To operate the pumps then, you had an operator physically going down and turning on and then turning off the pumps. He would maintain the levels of the water in there between the high and the low set points. The consequence of that was that there would be no automatic stop when it got to what would be its normal low level, so the pump could carry on pumping below its low level. The heating elements were located below that low level point, but there was a separate trip for them, so when the level got to the level of the heating elements, that should have stopped the heating elements. Now it was subsequently found that those levels weren't quite set up correctly, so it was possible in fact for the heaters to be exposed to air before they actually turned off. The condensate would have been floating on top of the water level, but when you've got these electrical heating elements, which are like what you see in a kettle, and the level of water dropping so that the condensate was actually exposed directly to those heating elements, you'd have had some of it boiling off and a cloud of hydrocarbon vapor being generated. Once you've got that vapor cloud in an air mixture, those heating elements ignited that gas cloud and that blew the roof off the tank and caused the fire.
I think our environmental focus really did skew our view tremendously on this plant.
Maybe there was assumptions made that when the wastewater treatment plant was first put in, that it would have been designed with all the same safety cut-offs, electrical regulations, etc., etc., and it's evident that this wasn't the case.
We've been living with that, effectively that time bomb for some time, and particularly in the continued operation of VG110.
It's recognising that you're on a hydrocarbon plant. Hydrocarbons are everywhere, so any small change could potentially have dire consequences.
On reflection, when we look back, I think we lost sight of some of the other areas which fundamentally we would have linked to any hydrocarbon process system, where we would have carried out risk assessments and ORAs, etc., for the safety and the operation of the plant itself.
That was something we hadn't done with VG110, and subsequently then with the wastewater treatment plant. So with the two issues, had we captured one of them, had we risk assessed one of those pieces individually or together, then we would have prevented what happened there.
I think the risk assessment is key, especially if you have changing operating conditions. And I think this is one of the things that we didn't do so well in this situation. Because of our belief, it's just a wastewater treatment plant and it can handle the condensate.
Think of the plant holistically and think, well, this piece of equipment's not working, but how does that affect the rest of the plant?
It's not easy to experience an incident like this, but also being allowed to stay behind and try to fix things, learn from it, and move on is actually quite important.
We dig deeper, we carry out an operational risk assessment to any change which will change the process and downstream facilities. So we don't just stop at, well, we think it's right, we actually check and verify that it is fit for purpose.
And asking ourselves those questions, those hard questions, on can we continue to operate this bit of process? Yes or no?
Sometimes you think you know how you actually operate the plant, but in reality you're already deviating for what it's originally designed for. So reviewing these things or reviewing the plant design and operations on a regular basis is paramount.
Don't just trust what you think you know, dig deeper and in real make sure that you do know.